Well, good evening. My name is Lukas Armstrong. I'm a principal and an architect at Cover Architectural Collaborative here in Nelson, BC. And I'm here to talk about Passivehouse. It's a passion of ours. We are actually responsible for the first multifamily certified Passivehouse in Canada at the time of construction. And you'll see sort of how the industry's been progressing. I've got some slides about that. The benefits and challenges of super efficient construction, and it's really interesting to follow Trish actually, because we've seen since we built my house, which is the house that was the first, back in 2012, we've seen rapid uptake of super efficient technologies across Canada and really across North America, and it's been ongoing in Germany and other parts of Europe for 20 years. They're very far ahead of us as usual. I'll talk a little bit about that. The 2030 challenge is something that we may have all heard of, and it's basically an effort to reduce our carbon footprint on the planet. And the interesting thing about the 2030 challenge is that it has a relatively long time frame. It does correspond somewhat with step code goals, and I find it both encouraging. It gives us something to shoot for, and there are tools being developed to help us get there. I also find it slightly frustrating because many of the tools to help us get there within construction are here now, and really, conceivably, governments could implement them quite a bit more rapidly than they are. I think, of course, some of the challenges of getting the infrastructure in place from the municipal and RDCK perspective is probably the biggest challenge. That capacity to handle the kind of information that will be coming in that they'll have to deal with, as well as training builders to be able to do this. Although I'm going to talk about how that learning curve is actually not as steep as many people may think. So as mentioned, the BC Step Code, and as Trish just finished talking about, they are aiming for net zero ready by 2032. My house was recently completed in 2012, and it exceeds slightly the net zero position that they've put up for 2032. So again, great framework. Let's get it rolling. It's a little unfortunate that it's going to take us about 15 years to get there, and it does mean that all the houses built between now and then that don't pay attention to this are going to be obsolete by then. And it's definitely something for new home builders to think about. The metrics associated with the BC code, BC Step Code, you'll note that Step Code 4, for example, we need air change rate of 1.5 air changes per hour. So that does represent how big of a hole in your house you have when you do that blower door test. My own home far exceeds that, and it's quite actually achievable. And the energy load that a house could have, Step Code 4, again, sitting here at, 40 watts per meter squared. My own home uses about 15 kilowatt hours per meter squared. So far in excess of Step Code 4. We're building a Step Code 4 building right now for BC Housing. This is my own home up on Bedford Road. As mentioned, our air exchange rate is, our air leakage rate, 0.2. So, we've got a hole in our building about this big. Standard construction has a hole in the wall, approximately, it's huge. And all of that air leaking out is taking heat energy with it and degrading your envelope. Our heat demand, 14 kilowatt hours per meter squared. So my own energy bill for all of our electrical use, for lighting and all of our loads, as well as our hot water and our heating, is costing me under $1,000 a year for my house. So the term Passivehouse, developed in Germany, and the use of the word passive is a little bit different than we think of it. So passive solar used to be, really dependent on the sun. Passive houses, from the German model, the word passive actually refers to less moving parts. We're really concentrating on the envelope and thereby reducing the size of the mechanical system, which reduces operating costs and reduces maintenance costs, etc. And it's, the whole intent is to reduce energy use. And unlike LEED, which maybe some of you have heard about, LEED was really a multi-point system that looked at all kinds of different sustainability components. and sometimes at the expense of energy. And Passivehouse takes the approach where energy is the most important because of the carbon footprint, and that good designers will think about those other things sort of as they're completing the rest of the design. Heating and cooling of homes represents 75 to 80% of the life cycle environmental impact, which I want to talk about for a second because green building used to be thought of, and in some circles still thought of, as using straw bale or clay chip and clay slip and a number of other sort of green technologies to create an energy efficient building. But it's not really energy efficient. It does have a lower ecological impact at the time of construction through its material use. But those materials don't have the same capacity to retain heat, and actually over the lifespan of the building, maybe it's 50 years, maybe it's 100 years, ideally it's 200 years, the impact of those materials is far outweighed by the energy use in maintaining and running the building. And so it's our position that building with some more technological components, using some high-tech membranes, etc., although it's not as green initially, is better for the planet in the long run, in the overall lifespan of the building. People are always asking me, how much does this cost? At the time of construction for my house, we built ours for about 180, 175 bucks a square foot, and we had a third-party quantity surveyor look at the plans as it was built and also as it would have been according to code construction. And the premium was about 10%, and that tends to hold true for residential construction. It's a little higher for commercial. Those building costs have gone up since we built our home, but that percentage ratio would more or less hold true. And so our position is get a good designer, and establish your budget, and build to budget. Build 10% less to pay for that energy efficiency, and your quality of life goes up substantially. Unfortunately, people always want to talk about payback time, but and it's a little bit interesting because nobody talks about payback time for a vehicle, which actually doesn't have one, or other kinds of purchases that we make that make our lives better, but don't have a payback period. Now there is a financial incentive, but it really is a long-term thinking. As you can see here, average home would save about $100,000, but it takes 40 years to do it. But our kids' generations will take advantage of that. However, it does bring immediate benefits, and these are some of them. Trish talked about them, and I've added a couple here. Because of the high rate of air exchange through a filtered system, you get improved indoor air quality, thermal comfort, sound insulation, the energy efficiency I've been talking about. And the building is more durable. There's less moisture being built up in the walls, so it eliminates the chance for black mold or dry rot and those kind of other degrading, the results of moisture in your walls. Depending on the material use, of course, you could get to an almost no maintenance building. Very resilient because moisture that does move into the wall tends to breathe out through the wall. As a result of all these things, are sustainable, and it's very versatile. We can build really almost any kind of style of home or building that people would want. And it's internationally embraced. So, unlike the STEP code, which is, the BC and eventually the national government trying to reinvent the wheel here, this is 20 years old, and in some respects, it's a little bit frustrating from the design community that this particular vehicle or technology isn't being adopted rather than having to reinvent it within our own government. But having said that, it's not unusual, so not completely surprising, I suppose. Like I said, it can be applied to all building types: commercial, residential, multi-family residential, schools. We're actually doing a car dealership, which I'll talk about. Bit of an oxymoron, but this is a global movement, that I said. At the time of this slide being taken, there were 6 buildings that were certified in Canada. I just looked at it today. There's now 20 certified, but there's probably about 300 that have been built to the standard, but maybe for various reasons didn't quite reach a certification or are about to reach certification. And there's actually some really amazing projects going on right now in Vancouver. I was looking, there's a couple of the biggest certified passive house buildings in the world will be built in Vancouver. I think there's sort of, I'm going to guess at about 500 unit towers. And so that's going to be pretty good to see, a great example. Passivehouse actually started in Saskatchewan, surprisingly, but then Wolfgang Feist came, saw the building, saw how excellent it was, and took it back to Germany and developed it further. And so, how do you design a passive house? And Trish kind of talked about this a little bit. It really starts at the beginning. It starts at the planning process. If you think you want to design an energy efficient building, don't come up with floor plans and then try to layer on energy efficiency on top. It really will not be as effective. What you need to do is start with energy efficiency as part of the design conversation at day one. Look at your site, design your building to the site, and start to layer the energy efficiency strategies on, and your floor plan almost gets generated in some fashion through that exercise. More specifically, you have to have an efficient building shape. We are concerned with solar exposure. We're not dependent on the sun, but we certainly want to include the sun in our calculations. Super efficient insulation, advanced windows, air tightness, as I've talked about. We do want an HRV, potentially with preheating if necessary, depending on your climate, and thermal bridge-free construction, which luckily BC construction practices are basically thermal bridge-free already because we use so much wood. In some countries where they use a lot of concrete and steel, or in commercial construction where there's more concrete and steel, it can be more of a challenge. But there are strategies to get around that. So my own home, a very platonic shape. It's a rectangle. We've got also, you'll see most of our windows are on the south facade, less windows on the north facade, a couple on the east and west. It's a triplex. Unit 1, 2 stories. Unit 2 on the ground, on the what is really the ground floor, and Unit 3 stacked above it. And so in section, we've got this basement underneath. It's an unheated storage space. And then 2 floors. This is the Passivehouse envelope around the 3 suites. And the assemblies that get us to certification include R110 in the ceiling, R68 in the wall, R64 in the floor between the basement and the upper floors. And you can see it here. And actually, we're learning all the time. This is a bit more complicated than I would build it today, but it's triple stud frame. So we built 2x6 construction all the way up to the roof, got us to lock up, got us to dry in. Then we were able to come back in a heated comfort, be able to put in a secondary wall that got our initial thickness, put in our air vapor barrier, and then an installation cavity. And I'll talk about the importance of the installation cavity shortly. At the floor system, which is often a big point where we can end up with thermal bridging, we use a little bit of spray foam. But most of the insulation that we use is cellulose, because cellulose is the most really ecologically friendly material. It's post-consumer recycled content, it's human health friendly, and it doesn't use a lot of petroleum in its production. The windows tend to be set in the middle of the wall, unlike Canadian construction that has the windows right on the outside. 5 minutes. That does a number of things, and you can see here one of the little nuances of Passivehouse is the insulation of your window frame. There's a lot of linear feet of window frame in a typical house. Those window frames are the most conductive part of your envelope, and it's important to insulate those. So that's one sort of, aside from the assembly itself, that's one nuanced detail that is part of that learning curve. The materials we use, as mentioned, you need that high performance window, and options for those windows are getting better and better all the time. There's a number of BC made windows now on the market. Not wood yet, I don't think. I think all wood windows are still being shipped by boat from Germany, but there are other types of materials, fiberglass, nylon, etc. As mentioned, we use cellulose. We do use some membranes, building wrap, right from the hardware store, and we actually use 6 mil vapor barrier on the inside. But our thinking around vapor barrier has actually changed, and now on projects that we're doing, there's no membranes to speak of. We're using taped plywood on both sides of the assembly because it allows moisture to move through the wall in both directions. It's a very durable system. Interior finishings can be what you would like. There's really no limitation. I'll talk about this for a second because this is the installation cavity in a kitchen. So that membrane you're seeing behind that is the vapor barrier, and all of these are the plugs that you would see in a normal kitchen, and every single one of those will be leaking hot, moist air into your envelope. Typical Canadian construction. They do a terrible job at sealing those penetrations, and as a result, kitchens are the worst for creating black mold and dry rot in behind all of those plugins. And so we build this installation cavity on the inside that has all your plumbing and all your wiring, and as a result, you don't have any penetrations and therefore no air leakage. And then anything that does penetrate, you tape up really well, and then you get down to that really low leakage rate. Mechanical systems, as a result of all this energy efficiency, mean that they can become quite reduced. We have one central boiler run by propane, and as I mentioned earlier, we spend about $1,200 a year for all 3 suites on heat energy. We distribute that heat through radiant panels, and we have an HRV system. HRV, heat recovery ventilator, so you get 100% air exchange all the time through a filtered system. They're quiet, and they make your house feel excellent to live in. Cover architecture, we're responsible for a number of projects. My own home, we've got a house in Kimberley that's under construction. We've just finished a triplex in Cusp. And we're doing the world's first certified Passivehouse car dealership, which again, being a car dealership is kind of an oxymoron, but if you're going to build a building, let's build it better. And you can see some of the strategies that I've talked about in the construction of this building. You've got a foot thick insulation on the outside of the concrete foundation, mostly wood frame construction, which is good for the environment rather than steel and concrete. That's pretty unusual for a commercial building of this size. Thermal breaks, so this is the outside concrete slab, this is the inside concrete slab, and we have a product in between that eliminates that thermal bridging. Got some pretty expensive overhead doors that are surprisingly airtight and have a very high insulation value and open and close in about 2 seconds. Not cheap though. We can use a lot of glazing because the glass is very high performance glass, and so surprisingly, even in Red Deer where they get a lot of sun, it doesn't overheat the building. It's a pretty fun project. We're also doing some step code work. This is a building in Grand Forks. We've reached step code 4. And the premium associated with the construction to reach step code 4, we're estimating at somewhere between 1% and 2%. So it's incredibly achievable. And the learning curve, it's really about air tightness. And we use 2x8 walls. And we've got decent Canadian made windows. And that's about it. There's really no reason why almost really every project should be hitting step code 4 right now. When you think about on most buildings, a design or construction contingency might be 10% on the budget already. So to have a 1 or 2% premium associated with reaching a 40% reduction in energy use, that's an easy decision to make. So the learning curve, it took my brother and I 18 months to build our house. It was we've never done it before, although we had built some similar projects in the past. And we spent a lot of time on design trying to understand how to make the house as close to standard construction as possible so that when we had to talk to other builders about their homes, really it's doing what we do already, just a little bit more of it. And it was really interesting being part of that construction process, understanding some of the challenges. The sealing of the air vapor barrier is probably the biggest one because we just don't even talk about it these days within Canadian code. But at the end of the day, really it's about some high performance tapes and appropriate application of those tapes in the right location. So again, the learning curve is relatively shallow, and I would encourage anyone who's thinking of building a new home to really take it seriously, start at stage 1, day 1, talking about it, and find a builder who understands. And that builder doesn't necessarily have to have done it before, but they have to have an enthusiasm to go out and find the information because it's out there. Thank you very much.